Hi, I'm Kerui Zhu, and I'm going to present Lab 3 Magnetic Field of Permanent Dipole Magnets. The purpose of this lab is to prove that there is a dependency between the distance and magnetic field caused by the dipole magnet, and we need to calculate the dependence using the on-axis experiment with the help of the equation I listed, and also we need to calculate and compare the magnetic field off-axis using both experiment and coding portion. The physical principles behind this lab is simple. So first of all, we need to apply Biot-Savart law for the calculation part. We also can know the direction of the magnetic field of a magnet using the diagram I pasted here. And also, Earth has its own magnetic field in the north to south direction. For the setup process, we need to make the magnetic field on the x-axis close to 0 as the calibration in order to eliminate the effects done by the Earth's magnetic field. We also need to find the magnetic center of the cell phone. After doing the setup process, for the first experiment, it's on-axis experiment, so we just move along this meter stick to find the distance we need. And for the second experiment, besides the first process I mentioned, it also needs to have another meter stick along the vertical axis of the magnetic center of the cell phone to get a 45 degree. These are the data I collected from my experiment. So for the first experiment, basically we need to record the distance to get the specific magnetic field. And for the second part, we also just record all the data we required from the cell phone app. And the diagram is automatically made by the Excel. The y-axis is line B and the x-axis is line R. This helps us to calculate the dependency later. So in order to get k and n in this equation, we need to simplify it first into line B equals to line k plus n times line R. And the y and the x variable in this equation is made into a diagram I explained before. The slope is n itself and the constant is line k, and we can get the k and n from my case. And after getting them, I can calculate the magnetic field using this equation when r equals to 0.191 meter. I can use another equation from Biot-Savart law to get the mu for our coding part. These are the coding part. So I plug in the mu I get from my calculation before, and here we need to make a function of calculating magnetic field using the Biot-Savart law equation. After that, I make 6 different observation points of the magnetic field. Basically, 2 are along the axis and 4 are perpendicular to the axis. I basically just manipulate the x, y, z axis values. After that, we just apply the function we made before to calculate the magnetic field and show them as arrows. These are the perpendicular arrows I made. And on the right hand side, we made another arrow from the observation point that is 45 degree from the horizontal axis in order to get the result and compare with our experiment result. So these are the results I get from the coding part. They are basically the same diagram, but the second diagram is looked from a better angle. And the white section represents the magnet. The orange arrows represents the magnetic field we observe along the magnet axis. And the blue arrows are from the other perpendicular observation points. The green arrow represents the 45 degree angle observation point. I get the distance from the 45 degree observation point in the coding part to be 0.27 meters. I got from my experiment that is 0.19 meters. And for the magnetic field, the coding part and the experiment part kind of agree with each other, especially for the x-axis value. But since the coding part value has a 0 magnetic field on the z-axis, it is reasonable that they have different y and z values. So here are some further discussions. So the first question is that what if that we didn't do the setup process to eliminate the Earth's magnetic field? The answer is obvious that the Earth's magnetic field would impact our result by applying the superposition law, and the result will be more inaccurate. And the second question is, what if we stick two identical magnets together? Would it affect the result? I think that theoretically it would not affect the result much. We only need to care about the distance to each pole in our experiment. So the only possible increase in magnetic field position is where it is super near the dipoles themselves, since we make the dipoles longer. Here's a simple conclusion. The experiment of the magnetic field helps us to visualize the concepts, even though it's not precise enough. And also I reviewed the application of Biosavat law.